GPT 4.1 is beating GPT 4.0 on many benchmarks, but they didn't launch one model, they launched 3 different models with all complex and weird names. How am I gonna keep up? 4.1, 4.5. Is 4.1 better than 4.5? You'll find out in this video. We'll start with what makes these models different. What is the price of these models, and then we'll take a look at a couple of benchmarks, a couple of demos, and then figure out how to use it. This is going to be a fun one, so grab your popcorn and let's get started. So the first thing we're going to talk about are the 3 different models, and it's actually funny that ChatGPT is launching this today because it kind of feels like exactly what I was doing earlier today, seeing the elephant go out of the water. This was incredibly cool to see today. And the other thing that was really cool that kind of reminds me of OpenAI versus DeepSeek. As you can see, we have ChatGPT on the right and DeepSeek on the left. Let's check what happens. The API is just that good. Or is it? Let's find out. So as you can see, we now have 4.1 Nano, 4.1 Mini, and GPT 4.1. But what is the difference? Well, if we take a closer look, you can see that the intelligence bar here just goes up, meaning that the GPT 4.1 is the more intelligent model. But on the speed, you can see that the Nano is way faster, and then it goes slower over time. For multimodality of text input, image input, and it seems like this is audio, well, you can do that on the Nano, and you can do it on all the models have just image and text capabilities. The lastly, for output, you can only get text, meaning we don't have any auditory or visual outputs that we can generate, like for example, images. That's completely fine. They also have no reasoning tokens. When it comes to pricing, you can see that the input of the Nano model is 10 cents. They have cached input that we're going to talk about in a minute at 3 cents and output at 40 cents. When we check this across the board here of Mini, it's also a little bit more expensive than what I was thinking. But that all comes down to how good is it really, right? So you can see here behind my face that the price is $2.50 on the cached input, and the output it's $8. Now, a way that they've tried to make this cheaper is to have cached input, meaning that you give an input and that is stored so it can be retrieved later, so you don't actually have to continue calculating the same things that you may have done before if you're doing the same prompt and again and again. That's usually what happens with software, so it's nice that they have that in there, and I haven't seen many others do that before. The big thing here is that the context window is 1 million tokens for every single model. This is huge. However, they only have a max output tokens of 32,000. Let's see how many words is that. It is roughly 24,000 words. And to say how many books that is, it's starting to creep up on the length of one novella and around 1/3 of a average novel that is roughly around 80,000 words. All the way at the bottom, you see that the knowledge cutoff is June 1st, 2024. So they're still using that data set to basically get the brains of the new GPT, and then they're using search to get additional up-to-date information. However, I'm not sure you can use the search through this API, which means that if you're going to do anything with recent information, you will have to feed it recent information and then get it to churn on that data. Now, the pricing is one of the things that I am a little bit interested to see, because we run API through automation in Make, and therefore having cheaper and more better, more better models is obviously what we want to get. And we found some great success in Gemini models, especially the 2.5 or the 2.0 Flash, have extremely low cost and give us really great answers. So let's compare the pricing there. Gemini 2.5 Pro is their best model at also quite a big price. Here in this case, GPT is a bit cheaper. As you can see on the input, $2 and $8. Let's check out Gemini. It's around $2 as well and $10 to $15 output. They also have the context caching, but it's not available in this exact model. Now on the Gemini 2.0 Flash, the input price is text, image, video, 10 cents and audio 70 cents. Output price, however, is 40 cents. So if we take a look at the cheapest models from OpenAI as well, you have the Nano 10 cents and 40 in the output, meaning that it's actually at the exact same cost. That is very cool. It'd be great to see an exact back-to-back comparison of Gemini 2.0 Flash and the new Nano model. You can also see that this is the cheap model here as well from Gemini that has the light model that is even cheaper than all of them. And also, it's a great model to use for not too complex AI API requests. So that was some info on the models themselves and the pricing, but let's take a look at the benchmarks that was presented by OpenAI themselves. They are talking a lot and saying that it's great, but what does it actually do? So we're gonna take a little bit of a look on this video here that they live streamed yesterday, giving us a little glimpse into what they think.
All right, today we're excited to announce GPT 4.1, which is a family of models in the API that were trained just for developers.
And the the 4.1 series actually improves a lot from 4.0. So you can see 4.0 and Mini in here are in green. And then 4.1, we have these 3 new models that kind of move that frontier upward because they're much more intelligent. You also can see that we have Nano as a new entrant in this area, and it's much faster, but also, really holds its weight on intelligence. So that's kind of the rough shape of the models. And,
So here, obviously, it looks like the 4.1 Mini is the bang for the buck model with high intelligence, low latency.
When deciding when to use them, we recommend starting with 4.1. And it's our kind of powerhouse for these 3 dimensions, coding, instruction following, and long context. But if you need something a little faster, for maybe a slightly simpler use case, I'd recommend 4.1 Mini. And then finally, Nano is just an absolute workhorse for, tons of applications like autocomplete or classification or extracting, stuff from long documents. So that's kind of when you should use each model.
So it's great to see that she's explaining the differences when you should use a less intelligent, very fast model there. And some great use cases.
But let's get into coding first. So, developers care a lot about coding, and we've been improving our model's ability to write functional code. And so what does that mean? We've been working on making it follow diff formats better, explore repos, write unit tests, and write code that compiles. And actually, SweBench is a really great eval for evaluating this sort of performance. The model is dropped into a Python repo, it's given a task, it's got to explore, write some code, write some tests. And we see that GPT 4.1 is a significant improvement over our past models. It reaches 55% accuracy, up from 33% from our previous GPT 4.0 model. And we think this is pretty impressive for a non-reasoning model. It even beats 0.1 and 0.3 Mini. But SweBench is all Python. And we've also improved this model's ability to code in other languages. And Aider Polyglot is a great benchmark for that specifically. It's got a bunch of languages, but also what's cool is that it's got a whole and diff format. So sometimes developers want the model to rewrite the entire file, but sometimes you want it to produce diffs. And that's useful when you want a faster application. You save latency on the tokens that are not changed.
Also save money, right?
Exactly.
Yeah.
And so here you can see that we've really closed the gap on whole and diff performance. We've also doubled GPT 4.1's diff performance from 4.0. You can also see that Mini is a really significant improvement over GPT 4.0 Mini. So we think both of these models will be a great great model for any kind of coding tasks.
My surprise here is to see that it's actually outperforming GPT 4.5. Seeing that it can do most of it, and if you actually saw the last one as well, you could definitely see that is 4.5 already gone? I kind of liked 4.5, but it seems like it's not performing to par with some of these tests, especially on coding.
So those are coding benchmarks, but there's also kind of the intangibles of when you're using a model. You know, when you're creating a front end, is it functional? Is it beautiful? Does it nail the mark? And so for that, we have a little example of a flashcard app I've been making.
You're learning Hindi.
Yeah, working on it. And so I've got a prompt here. It's pretty complicated. I'm asking for this app pretty specifically. I want a nice 3D animation when you click on the flashcard. And so when I give this prompt to GPT-4o, this is what I get. It follows some of the instructions and some of the app is functional. But we really trained GPT 4.1 to do better. And that model, you can see it looks way better. It's discovered colors. It can also do the 3D animation. So we think you're really going to like this improvement to front-end coding.
And this was just based on that prompt that you gave it?
Just one prompt, and you get back an entire working application. It's pretty cool. But we've also been working on instruction following. So can you tell us a bit about that?
Yeah. So
Am I the only one that wants to put this into Gemini 2.5? Let's just grab the exact same prompt. Hold on, we'll go back to ChatGPT in a moment. Okay, I'm gonna use the exact same prompt, click on Canvas and go. Look at all this code. Here we go. Let's see if it's satisfying. No 3D flipping of the card, no colors. There is a create, there is a search, there is a stats as well. But yeah, it didn't perform as well as 4.1. Very cool. Onwards, let's see the example again.
And that model, you can see it looks way better. It's discovered colors. It can also do the 3D animation. So we think you're really going to like this improvement to front-end coding.
and this was just based on that prompt that you gave it?
Just one prompt, and you get back an entire working application. It's pretty cool. But we've also been working on instruction following. So can you tell us a bit about that?
Yeah, so just like coding, we have made the model way better at instruction following. It now strictly follows all the instructions that you provided. So using all the feedback that we received, we created this internal instruction following eval, where it mimics how an API developer uses our model. So each sample in the eval contains a complex set of instructions, where each instruction belongs to one of several categories, like formatting, ranking, ordered instructions, overconfidence, and so on. And collectively, that sample is given a difficulty rating from like easy, medium, and hard. And we see that this model does really well across all those axes and on difficulty levels as well. So here you can see the hard subset eval results, and this model is so much better than the previous 4.0 model.
So what's an example of like a really hard set of instructions to follow?
Yeah, so let's say you're building a trip planning application, and you give it instructions like make sure you receive all the info from the user before answering them. And when you answer with the trip itinerary, make sure it's in a table format. It contains 5 rows, 3 columns. The columns are formatted in a certain way.
Yeah, I don't know about you all. I remember all the times that you learn these tricks in prompting where you're like, no, you really need to make this a table, not a list. Trust me, my boss is going to be super mad at me if you don't get this right.
Yeah,
so hopefully no more of that.
Yeah, and people actually were doing that just so that they could get the model to follow an instruction. None of that is needed now. The model follows all your instructions to the T, and it does really well.
Follows your instructions to a T. That's overstating right there. I believe there's no way that's true.
Also have a new prompting guide now that we'll publish on how to get the best out of our models.
Awesome.
And not just internal evals, even on external benchmarks like Scale's multi-challenge eval that tests models' instruction following capabilities on multiple turns, our model does really well. So for example, you might have an instruction 3 turns ago, and it tests whether the model remembers that instructions and continues to follow it. So it also tests models' coherence and memory. These improvements also scale well on long context data too. So you could give it large corpus of data, and the behavior that you're trying to extract from the model, it'll continue to follow that.
Nice. Yeah, speaking of large corpuses, GPT 4.1, Mini, and Nano are our first models to have 1 million of tokens in as the context. This is up from 128K for our past models, so it's an 8x improvement, which is pretty big. But it's not enough to just have the context. You want the model to be able to use it effectively. And so for that, we're showing this eval we created. which is a needle in a haystack. We insert some kind of text into a large corpus, and we ask the model to find it. And we see that the model can find it across any depth, so maybe at the beginning, the middle, or the end of the document, and also across the entire.
So what she's saying is that it was able to find it through all of it. Complete successful retrieval. That's really cool. Because have you had that issue as well? You put a lot of context in, you ask it about something, and it can't actually find it. Very cool.
Entire full length of the context up to 1 million.
This is a very boring looking graph, but it's boring in a great way because it says every square is actually working.
Yeah, it's actually boring through so much work, which is so cool. Normally you would expect to see some of these be red, like, the long context doesn't hold up to a certain area, but the fact that all of these is blue means that the model can find what you're looking for.
And this is for all 3 models?
All 3 models, even Nano. So this is not, the end-all be-all of long context. It's nice to find a detractor in a long document, but that's not exactly what all our developers are doing. So we've also created an eval called OpenAI MRCR, and this is a kind of more challenging way of determining how well the model does on long context. So you can see that GPT 4.1 in blue exceeds GPT 4.0 in green significantly, up to 128K tokens, and it holds up quite well all the way up to 1 million tokens.
This eval is actually really complex. Can you explain it a little bit more about how it works?
Yeah, it's pretty complicated. So we basically create these synthetic conversations where there's a user and an assistant talking back and forth, and the user is asking for things like, give me a poem about tapirs, and then give me a poem about frogs, and then maybe give me a short story about tapirs. And then we ask the model, find me the second short story about tapirs. And so you can find, it's pretty complicated. You have to not get confused by the poems and the frogs, and find the second and not the first one. So we're really excited about this improvement in performance, but you can see that there's still some work to do here. And so as part of that, we're publishing this eval on Hugging Face today, OpenAI MRCR, and we really want to spur on more work in the kind of more difficult long context processing area. And then more.
One important thing to note here is that context window isn't only important if you bring it a lot of information all at once, it's also important if you have a long chat history. It can read a long time back in the chat history to remember what you've been talking about, which makes the next prompt so incredibly more specific if you've been prompting with it for a while. Now, this is through the API, so try to think of that if you're doing the code as well, how you can utilize that to give the best results to the user. Also, the one interesting thing to note is that you should subscribe to the channel. We're trying to hit 1,000 subscribers on this channel right now, and with your help, we might be able to make it. All right, let's keep going.
More on multimodal long context. So sometimes you're not just using text, but you also want to upload a video. And we found that on the video MME benchmark, GPT 4.1 reaches state-of-the-art performance, achieving 72%. So this benchmark is pretty cool. You upload like a 30 to 60 minute video without subtitles, and the model is asked multiple choice questions. So GPT 4.1 is much better at understanding this sorts of thing. All right, and then one last hit on evals, a lot of plots, I know. On multimodal processing in general, these models are a really significant improvement, but the real story is GPT 4.1 mini. This model, you can see it really punches above its weight on multimodal reasoning and intelligence. And we think this is probably the top model to be used if you're doing any sort of multimodal or image processing.
Very cool. If you're doing image processing, sending images to it, that seems to be the model to go with, a lot cheaper, and it can also accurately tell what's in the image. So yeah, I would switch to that one right away. So those were some of the benchmarks, but give us a demo.
So here we have the OpenAI Playground, which is a really nice UI to iterate on OpenAI's APIs. I've pre-selected the latest 4.1 model, and in the system message, I've given it a light identity. The identity is it needs to produce a single Python file code application with very limited setup required. I also told it that it has access to the latest 4.1 model, which can handle up to 1 million tokens of input and 32K out. So on the right, we mimic a user query. So the user is asking to make a website that can take a large text file and answer questions about it. We give it very limited style guidance, and we tell it to use OpenAI's responses APIs to answer questions about the doc.
So you're having, as part of the demo, you're having it create a website, and then you'll use that website for the rest of the demo.
Exactly.
Okay.
Yeah. So now it's
meta.
producing like multiple hundreds of lines of code. I've rerun this query before, and I've copied the code that it spits out into this app.py file. So you can see it's a multiple 100-line file. You see that the HTML has been inlined in this file. If you keep scrolling, you would see there's an upload code, the code to ask questions. It's going to hit the responses API.
So the model did this just in one shot.
Yeah, it's doing that right now as you're seeing it. Yeah, let's produce the code. It tells you how to spin it up.
Cool.
Yeah, should we take it for a spin?
Let's do it.
Yeah.
It would be
Nice.
fun if he actually ran into an error and then he just copy pasted the error message into ChatGPT asking it to fix.
That looks pretty cool. It's a little B2B sassy, but I think it's working.
I do like that it advertises itself there at the bottom, powered by GPT 4.1.
Yeah, it's kind of neat. Just based on the limited guidance that we gave it, it produced this website. So to test the log file that I'm about to upload, that file is NASA's server request response log file from 1995 August. Let me show you that file.
You just have this file lying around?
Yeah, you don't?
I prefer the 94.
Oh,
The 94 is a great version.
that's a good one, yeah.
Agreed.
So in this log file, you can see the client name in the left that made the request to NASA's servers. You see the timestamp, the resource that was accessed, and the HTTP response code. This is a long file that contains a lot of log lines. And you can see on the left that this is about 450,000 tokens of content here.
Nice. So you just couldn't use this with our past models.
Yeah, this wasn't possible. So let's try uploading this file. Now what I've done is I've snuck in a line that is not actually an HTTP request response. Let's see if it can find it.
Very sneaky of you.
Okay,
So again, trying to do that nail in the haystack prompting to go on quite long context window here.
it's a little needle in the haystack, except in this case, you don't even tell it what the needle looks like. It's just figure out what's different and tell me.
Exactly. So it's going to sift through the whole file, do some pattern matching to see how all the log lines look like, and then try to see if there's one that does not look like the others. Okay, there is a line that it has spit out that does not look like an HTTP request line to me.
It does not.
Okay, let's see if this line is indeed in the log file that we uploaded.
Nice.
Yeah,
There it is.
Great. So it was able to find this line that has been snuck into this deep 450,000 token log file that is like very hard to find. So did pretty well.
Nice job, GPT 4.1.
Let's look at another demo.
Awesome.
Okay. So here we are going to riff on the previous demo that we saw, but this one is going to be more focused on how an API developer prompts our model. So I've again selected the 4.1 model here, and here the application's personality is of a log analyst assistant. We tell it how the input data will be structured. So we tell it will be within these log data tags, and how the user's query would be structured. So that would be in the query tag. And then we have a set of rules. And I've preloaded the log file here. So this is the trimmed version of the same log file we saw earlier. So I first made a request saying how many requests were made by fnal.gov, and it rejected it because it was not formatted within the query tags. Now I'm going to make the same request within query tags and see how it does. Okay, now it was able to find the two references that are within the log file. So this is the kind of interaction we see quite a bit with 4.0, where users want a certain behavior, and especially certain behavior not to happen, and the model sometimes misses on it. So I have an example. I made the same query to 4.0, and it answered the question instead of saying that it needs to be wrapped in query tag.
Yeah,
So, yeah.
that's a key detail we hear a lot from developers. You really want it to follow negative instructions and do exactly as specified.
Exactly, yeah.
So that was some cool tests, and it does seem like it is performing really, really well, especially on these specific tasks. And there isn't much more in this video because we already talked about price, but there is one, and it's right here.
We want to make sure that we can get GPT 4.1 out as broadly as possible to all of you. And we've just been talking about how 4.1 beats even 4.5 on a lot of key benchmarks. So we're announcing that we're going to be deprecating GPT 4.5 in the API. Not today. It'll happen over the course of the next 3 months or so, but we really do need those GPUs
What they said was June 1st, 2025.
back.
Yeah, we're really excited to get some back for research, so thank you.
Yeah, and I know we all love GPT 4.5. A lot of the improvements that we've made are going to continue on in this model and in other models, so it has been a very successful experiment.
All right, so that's cool and all, but what are people saying about it? Well, the number one criticism is, of course, naming convention. So How about we fix our model naming by this summer and everyone gets a few more months to make fun of us, which we very much deserve until then. Looking forward to GPT 3.7 Sonnet. Is that 3.5 months from now or 4.1 months from now? You should release a super vibey model on Sunday, GPT 4.20. This guy is saying that 4.1 has basically replaced O3 Mini for me in all my workflows. And he's posting some of these benchmarks that are looking really great. Important to note, he's saying 4.1 here, the most expensive model. Lastly, again, if it wasn't clear, it is only a change to the GPT API. You will not get access to it if you just open ChatGPT and check one of the models in the top. You will not find it here. However, let me tell you exactly how to use it. Just go to platform.openai.com, click on login, and here you are able to use it. As you can see, when you click on prompts, you can click on the model in the top, and here in the top of this list, you will see for 1 mini, and for 1 nano. If you haven't prompted in here before, you can write a system message that is kind of like custom instructions to give it some guidance. But if you just want to chat with it, hey, how is it going? Hey, I'm doing great. Thanks for asking. How about you? I'm doing great. To recap, while we're looking at me just driving in a golf cart around temples all day, you now get 3 different models. They all have really good pricing. The evals are looking really great with it. You can see that it's a little bit more detailed oriented specifically on the context window. And of course, it sticks to the instructions better than before, to a T. Remember that, it's to a T. Now, if you still haven't learned how to use these in your business, I highly recommend checking out AI Mate in the description down below. We can help you use AI tools and processes to turn something that takes you 3 hours to do down to just 15 minutes with AI tools and automation. Highly recommend checking it out in the description, AI Mate. That's all for today's video. Thank you so much for watching. I'll see you in the next one. Peace.